Hi class, how are you today? That's funny! The learning target for today is to use trig ratios to solve word problems. Scale for a 3, you can use trig ratios to solve word problems. 2, you can find all the missing measures of a right triangle using trigonometry, which was a 3 in the last video. 1, you can find the trig ratios of right triangles. And 0, you cannot find the trig ratios of right triangles. Let's get started.
Alright, so in this problem, they say the peak of a mountain is 400 meters high. So, let's say we've got our mountain, and it's 400 meters. Then the peak rises above a point 2,025 meters from the end of a local airstrip. So the length here is 2,025 meters. A plane takes off from the end of the runway. That would be right about here. In the direction of the mountain at an angle that is kept constant until the peak has been cleared. If the pilot wants to clear the mountain by 50 meters, so before we do anything else, it wants to clear the mountain by 50 meters. So, if this is 400 meters, we want to go up another 50 meters. Which would make a total of 450 feet there. So, what should the angle of elevation be for the takeoff to the nearest tenth of a degree? So the key word here is angle of elevation, or key phrase. So the angle of elevation is the angle from something going up in a diagonal pattern, and they want to know what that angle is. So it's the angle of elevation for the takeoff of the plane. So if we draw our triangle here, the angle of elevation is what we want to know. So we'll call that our x. So in this problem, we have an angle, and we know its opposite side, 450, and its adjacent side, 2025. What trig function has to deal with opposite and adjacent? That would be tangent. So the tangent of the angle is equal to opposite, 450, over adjacent, 2025. So that means that x is equal to the inverse tangent of 450 over 2025. So x equals about 12.5, because they said to the nearest tenth of a degree. So 12.5 degrees. See, not much difference from what we've been doing, just doing a little bit more to draw the triangle from the words. So in this problem, we have Olivia works in a lighthouse on a cliff. So let's draw. That's the lighthouse on the cliff. And she observes two sailboats due east of the lighthouse. So sailboat here, sailboat here. The angles of depression. Now, angle of elevation was looking up, angle of depression is looking down. So if she's looking right here at the top here, she will be looking down. Now, the angle of depression is how many angles down it is. So if she was looking at eye level, that's my best dotted line on an iPad, the angle of depression for each of these, so for the first one, it's an angle of depression of 33 degrees. Now the second one is an angle of depression of 57 degrees, but that includes all of that from the line of sight all the way down to the second, so that combined is 57 degrees. So then it says the top of the lighthouse is 185 feet above sea level. And it wants you to find the distance between the two sailboats to the nearest foot. So in this picture here, we essentially have two triangles, one of them being a right triangle, or three triangles if you really look at it, but two right triangles. So they want you to find this measurement right here, x. So in order to find that measurement, you essentially will have to find the measurement of the two right triangles. So you'll have to find this measurement, this whole measurement here, and subtract it from this measurement here. So we essentially have two different triangles here. Two different right triangles that we're going to solve. I think to make this easier, let's draw two new triangles. So we'll call the left triangle this small triangle here, and the right triangle this big one here. So first let's plug in our measurements we have. We have the height of each of these is 185 feet. And now we need the degrees of this angle in both of these. Now we weren't explicitly given that. We were given that this was 33 and this whole thing was 57. We also know if this is a line of sight, that means this right here is a right angle. So to find the smaller one here, we'll just take 90 and subtract 57, which will give us 33. And then for the big one, we'll just say 90 minus 33, which is 57. So, anyone not listening to my voice will not understand how we got this and mess this up. So, you better be listening, not just watching without audio. So, this 33 came from 90 minus 57, which just happened to be what this is. It won't always work like that. It probably will never work like that again. It's just how the example worked out. And this 57 did not come from this. It actually came from 90 minus 33. So now let's solve these two triangles. So we have 33 degrees, 185 feet, and we want to find this. Let's just for using different variables, call this y. So this angle, y is opposite, 185 is adjacent, it's going to be tangent. So tangent of 33 equals y over 185. So multiply both sides by 185. And that'll give us that 185 times the tangent of 33 equals y. So y equals about, and let's round to the nearest 4 decimal points to be safe, so 120.1404. Now you want to do the same thing in the other triangle. So let's just call this z. So we have tangent of 57 is equal to z over 185. Multiply both sides by 185, you'll get 185. Tangent of 57 equals z, so z equals about 284.8750. Then, now that we found those two, in order to find x, we have to subtract those two. So x is going to equal the bigger one, 284.8750 minus 120.1404. And just a reminder, they wanted it to the nearest foot. So that means we have to round our answer. And so 284.8750 minus 120.1404 will round to 164.7, and so that would round to 165, the nearest foot. So after all that, this is our final answer. So this one got a little bit more confusing because it involved two triangles, and then we had to deal with that.
Now time for the sponge. So, from an airplane at an altitude of 1,200 meters, the angle of depression to a building on the ground measures 28 degrees. How far does the plane need to fly to be directly above the building? So that's what I want you to find. How far does the plane need to fly for it to be directly above the building? Alright, that's it for the lesson. Once again, please make sure to take notes on the entire lesson, rank yourself, attempt the sponge, take a picture of everything, submit it all to your backpack, and have a good night.